I am representing the FP Insurance Group to present its argument in the pump station fire case. Texas Builders Construction was hired by the Water Management Department to renovate the storage room in the basement of the pump station building, as you see here. While working inside, shown here on the left side of the screen, the welders caused a fire that resulted in damages to and inside the storage room. Highlighted here, these two columns, this one and this one in the corner, were buckled due to the duration and temperature of the fire. Looking at the resulting images shown, you can only begin to understand the extent of the damages. However, the severity of the damages, as can be seen here, were not limited to just the storage room and columns. Upon inspection to the pump station after the fire was suppressed, the operating manager noticed this pipe here and the pump shaft on the ground floor incurred damages as well. By running a post-incident structural analysis using the finite element analysis software, we are now capable of having a deeper understanding of the succession of events and the cause and effect relationship of the fire in regards to the damages inside of the pump station building. Specifically, by running the software, we can see the failure mechanism and the causal relationship between the fire inside the storage room and the damages to the equipment in the other parts of the building. Before moving to the analysis result, I need to explain the structural system of the building because it is important to understand for the analysis. As you can see here in the model, the pump station is a two-story building with a basement and the ground floor. This building has steel beams and steel columns with concrete roofs and floors. Also, the pump station building has individual footings under the columns and strip footings under the walls. To investigate the causes of the pump shaft failure, we have compared the deflection modes before and after the incident using the finite element model. As you can see here, this is the deflection of the beams under the damaged pump. Before the incidental buckling, we noticed small and negligible deflections in beams, particularly under the pump shaft. However, when these two columns buckled under this new condition, we have a significant unbalanced deflection in this beam, amounting in a total of 2 inches, according to the analysis result. Now, let's take a look at the specifications regarding the allowable deflections under the pump to see how this large deflection would affect the pump shaft. Here, we have the pump shaft manufacturer's catalog. According to this catalog, the maximum allowable deflection on the shaft is 0.25 inches, which is smaller than the unbalanced deflection caused by the buckling of these two columns. So, we can deduct that our post-incident analysis proved that the pump shaft break on the ground floor is the result of the fire inside the storage room. This was caused by the unbalanced deflection under the pump exceeding its designed tolerance. Another damaged area resulting from the fire occurred outside the storage area. In addition to the pump shaft breaking on the ground floor was the damage of this pipe located in the pipe room next to the storage room. I have highlighted all the damages on the basement in red. And as you can see here, this pipe was tied to this column, so we thought, and therefore this damage may have been the cause by the settlement of the footing. Investigating these two columns buckling and not performing and bearing the loads from the building, we analyzed the changes of the footing loads in the building after the fire, ultimately determining the cause of the failing mechanism. Footing loads are the portion of the building loads which are transmitted into the soil from the connected structure above the ground through the footing. To analyze the footing loads, we use the finite element analysis software as we did for the building deflection mode. Here you can see the analysis result for the building before the incident. Under this condition, column A and column B have the higher loads in the building. Under column A, we have 210.7 kilopound force, and under column B, we have 163.9 kilopounds of force as the footing loads. If we divide these values by the dimension of the footing, which are the same for all individual footings, we get 4,300 pounds per square foot under column A and 3,345 pounds per square foot under column B. As calculated, the pressure on the soil both are less than 4,500 pounds per square foot before the fire, which is the allowable pressure on this specific soil, according to the geotechnical report for this location. So, according to the analysis, we can deduct that the settlement of the footing from this building before the fire incident was very unlikely. When these two columns buckled as the direct result from the fire incident, according to the analysis result, we get 5,600 pounds per square foot as the pressure on the soil under column A and 4,551 pounds per square foot as the pressure on soil under column B, both higher than 4,500 pounds per square foot, which is the recommended soil bearing pressure according to our geotechnical report. When the footing load becomes greater than the allowable soil bearing pressure occurring in this case, consequently, we expect footing settlement under columns A and B, leading to the pipe breakage in the pipe room, because, as I mentioned previously, the pipe was tied to the column B. Therefore, according to our analysis, we deduct that the pipe breakage was the indirect consequence of the fire incident inside the storage room. Demonstrated in our investigation, and unilaterally understood by most, the plaintiff, FP Insurance Group, believes that the defendant, Texas Builders Construction, is liable for all damages inside and outside the storage room. This includes the buckling of these two columns inside the room, the pipe breakage in the pipe room next to the storage room, and the pump shaft breakage in the pump room on the ground floor. The plaintiff seeks fiduciary equitable compensation amounting to the cost of the repairs. The Texas Builders Construction declined its responsibility for damages outside the storage room, claiming that the accessibility issue of the building to the storage room slowed down the firefighting process and the existence of flammable materials added to the intensity of the fire, which were out of the contractor's control. This defendant also claims that if the columns resisted the fire according to the standard, the damages outside the storage area would not have occurred. However, this claim is not acceptable because of our contractual agreement succinctly stating the contractor is liable for all damages to the building during the work with no exception. Thank you for your time and attention to this presentation.